So what we're going to do in this session, and he is correct, we're only going to go until 12:45, is we're going to go ahead and look at some of the network mysteries that are up on the Wireshark webpage. My name is Betty DuBois. And we've got a couple movies up on the website. The first couple movies are on the Wireshark website are done by Gerald Combs, so obviously you should watch those. And then the rest of the mystery videos are done by me. Just to let you know, they are all real live network issues. So they're all from customer sites. Now, that's why sometimes in the video it's kind of blurred. It's because you're not supposed to see certain things. So the trace file that y'all are getting has been filtered. So just be aware that it's not the whole story, but you can't have the whole story. So what you have is the main issue though. Okay? So, and then the one for tomorrow has actually been edited to hide the identity. So I actually went and edited every single packet in that trace file. Yeah. Yeah.
Oh,
yeah.
Thank you.
A little while. And
bless your heart.
I know. Yeah, because it did suck to do me that day. And ironically enough, my tomorrow my session is at the same time as like one of the guys who's doing the trace file annexation. You know, Jasper. I'm like, are you kidding? I needed that so bad. I needed to be in that spot. But anyway. So yeah, so they're edited and they've been filtered. So just forgive me, but you know, I'm sure if you were one of my clients, you wouldn't want me to get off your trace files either. So I can't do that. So they have been edited a little bit. Okay, but I tried to maintain them as much as possible. All right. So you know, it's one computer, one server. It's an open source FTP server. So be patient, keep trying, don't give up. Okay. And also, too, once you're done with a stick, just hold it up, and eventually someone will tap your shoulder and ask for it, okay? Now, so what we're going to do today, or in this session, is you've been called to solve a mystery. I'm a consultant. I go out and I capture traffic live. I also do training for Wireshark University. That's how I know Wireshark. And I've been doing protocol analysis since '96. So, you know, just a day or two. All right, so you've been doing this a little while, and I often get called to come into a client and there has some kind of problem. And now the question is, where do you start? What questions do you ask? What tools do you need? And once you have the traces, now what do you do? All right? Oh, hey, we got a stick up in the air. Anybody want it? There we go. Pass it on down.
Who wants it?
Because often, I don't know if this ever happened to you, you're looking at a trace file, it's got a couple 100,000 packets in it, and 4 hours have passed, and you're like, I was supposed to be doing something. I don't remember what it was, but there's like really good stuff in here, you know. And why is that doing that? Because it's not supposed to even be talking to them, and what's up with that, you know? So how to go ahead and look at certain things. That's what we're going to talk about. Now, the client interview. You know, when I started, you know, when I was young, stupid. When I started, I would go ahead and just start capturing and then start looking at it. And then 3 days would go by and I still haven't found the problem. So as I got older and more efficient, oh, and by the way, I have twins, so I'm efficient by nature. Okay. So as I got more efficient, I discovered how much more important it is to do the client interview and to do the client interview properly. The more questions I asked and the more people I asked the same questions of, the faster I could resolve the issue. So, want to think like a reporter and ask the 5 W's. And actually there's 8 million more that you should ask too, but we're going to start with this and it would only fit on one slide. So look at things like, who is complaining? You know, are there people that are complaining all in the same physical location? Are they in different physical locations? Is there a pattern in the locations? You know, everybody's whining in Boston, and yet the people in Atlanta seem to be happy. What's up with that? So is there any type of pattern to it? Okay. Then, if they're in the same location, is there pattern to the subnets? So if I start to do a lot of different interviews with different people, how many, the more times you ask, well, who has already called you? And who has asked questions? And who has said this? And who has mentioned that in the lunchroom? Those kind of questions you start to get a feel for is in certain departments, which may be different subnets. Okay? Then, what? What are they complaining about? If they're just like, well, it's slow. Well, could you be a little more definitive there? Okay. And you'd be amazed how many times people will go ahead and send me an email. Can I just send you a trace file because they're complaining it's slow. All right, sweetheart, you're going to have to give me a little more to work with. Okay. So those kind of questions. So for example, which specific applications? Now, if I have an application that's slow, one of the things that I need to look for is, are there interdependencies, okay? And does it depend on anything else? So for example, if I want to use this particular application, do I have to authenticate somewhere else in order to have rights to it? How many of y'all do Active Directory? You're like, oh, I don't even want to admit it. Okay. This is the audience participation part. Okay, if y'all been to Bettyland before, you know you have to jump in. Okay, so so if I have any type of interdependency and I have to get access to those other types of servers, I have to know that, and I have to know that ahead of time. So for things like, for example, do I use an LDAP server to even find that service? Do I hit a radius server to go ahead and get authentication? Somebody somewhere give me a map of how that application actually works. Now, who's in Loris's session just now? Okay, wasn't that cool? Wasn't that like it showed the map and like this thing draws to that? Oh my God, I love that. So, yeah, that's what I want. I want somebody else to draw the map for me, right? So, however, I don't have a profiler yet, and but I do have a shark at my house. Okay, see if it was call me, come play. Now, but I don't have a profiler, so I don't have something that'll go ahead and draw that for me. So what I have to do is actually interview the humans, all right? And ask because you'll get different information if you talk to the server administrator, the database developer, the sysadmin for the Windows box. Each different person that you ask, you'll get different information. And granted, they may tell you a different story. But if you mesh it all together, it's a lot faster when you go to look at the trace file. Okay? The goal of a consulting engagement is to spend as little time as possible looking at that trace file. I mean, not that I don't want to look at trace files, because I do. That's all I do with my life. I have no life. So I want to look at trace files. But I want to have a goal at the end. Okay? Oh, and like not to be really personal with y'all or anything, but when I go to do a consulting engagement, I bill by the day. So yeah, I don't bill by the hour, I bill by the day. So if I find a problem by 9:30, I get to go home. So I'm very focused on trying to get as much information as possible. Okay? Next one, where are the clients and servers involved physically? So trying to figure out where I'm going to go ahead and do things like put a tap in order to gather this data in the first place. Okay. Oh, we got one stick up at the top. Anybody want it coming down? There we go. He's there in the blue. Awesome, thanks. Okay. So I've got tabs, and I'm going to need to know where those servers are physically so that I can go ahead and get that type of information actually into my Shark appliance or into my Wireshark or into whatever data capture device I want to use. I have to have information about where those things are physically. Okay? So then the infamous, when did it start and how long has it been going on? Is it intermittent? Is it constant? And why did you call me? That's also a very interesting question, and get a lot of information from that. Because if the issue is they don't have time to deal with it, they're not going to have time to deal with you asking all of these questions. If it's just they don't have the expertise to look at it, then you'll know they'll be more likely to go ahead and answer your questions. Because a lot of times it's very frustrating. You go on site, work with a client, they're having all these problems, but because they're having all these problems, they can't even answer your questions, and you're walking in blind. It's not like, well, can't you just put a sniffer on that and go ahead and figure it out? No, baby. I can see IP addresses, but I do not know who all these people are. All right, you have to help me. So if it's a time issue, be aware and put that into your bill rate that you might not get as much assistance as you would like answering those type of questions. Where'd my clicker go? Up there it is. Okay. So tools. Wireshark. Duh. Okay. And so I use TAPS, physical layer 1 device, to go ahead and get the most precise delta times as possible. Right? That's why you want a layer 1 device for really precise delta times. Any of y'all are in financial world, brokers. There we go. No, not brokers, but broker houses, that kind of thing. Not actual brokers. If a broker gave me this thing. Okay. But financial transaction, or if I'm doing like a credit card clearinghouse type of transactions, in that environment, microseconds matter. Okay. Yeah. Oh yeah. I swear, the brokers can tell 10 microseconds from 8 microseconds. I swear to God, they can. Oh yeah. Oh yeah. Yeah. Okay, we got another stick hanging up. Anybody want it? Ooh, all the way up top. All right. Oh, and one coming down. Okay, throw it to me and I'll throw it to him. There we go. Okay. All righty. So, so microseconds matter. So in that environment, I'm willing to pay for a tool that might cost a little bit more, but a tool that can go ahead and get that type of response time, because so often the reason that they'll call me is because of a response time issue, and the network guys call me to prove it's not the network. I mean, I'll just be honest with you, that's usually what I do. So if I need good response time information, I need a physical layer 1 device. I need a tap. Now, the mirror switches, oh my God, these are so great, right? And I have mirror switches for at the client because, I'm just a little schleppy Betty, right? I gotta pay for all these things. So I, kind of like the cost-effective solution also. So I have some hardwired mirroring taps. They're not like, how a Cisco switch, we go ahead and configure it to do a span session, right? Okay, which means I have to touch the switch. I don't touch the switch at the client because if I make a loop, okay, then, so I do not want to go ahead and configure somebody else's switch. Plus two, oftentimes, because of, all right. Oh, that's right. Are you still trying to get in bless your heart? Okay. Since yesterday, he's been trying to get, Wireshark for native in Leopard, Snow Leopard, and and we didn't have the X11, and then we had to download that, and what have you. Right. Yeah. You copied over the files, all right? Yeah. Okay. You know me. I will give him to you.
I've got Wireshark on Mac, so no Windows machines here.
There we go. I run Windows. Please don't think less of me. Okay. Anybody else want me? Okay. Oh, this would be fun. All right. So I think you have these files. Okay, you probably do. All right. This would be funny. Okay. Let's see if I can make it all the way up to. Okay. Ta-da! It's funny because the lady sitting in front of you is like, oh, please don't whack me in the head with that stand. Okay. So, alrighty. So, okay, oh yeah, alright. So the reason, alright, so we don't want to go ahead and set up the span session at the customer site. Okay. So I have these, and what I normally do is I put my taps, my big dogs, at the servers, And then I take my little dogs and put them there at the client. And then I turn on the thickest southern accent I have, and I sit there next to the client and watch what they're doing, and I'm like, all right now, I'm going to watch what you do and see how your screen is, and now you tell me when it's slow. And that way I can go ahead and capture what they're doing. And I give them a little batch file that put on their desktop that pings the default gateway. And I'm like, all right, now go ahead and open up the application. Okay, now stop, now run your little batch file. All right, go click on that for me now on the desktop. Okay, and then I go ahead and have them log in. And then I'm like, now, wait. Go ahead and double click on your little batch file now. Go ahead and do that for me again. All right, and then now we'll go ahead and we're going to look up some customer information. Now, wait, don't click on that yet now. Go ahead and double click on your little batch file for me now. Okay, and that way I have, at the client session, a ping in between each process. So when I go to look at the trace file and try to figure, number one, I get to physically watch what they're doing. And then number two, I get to go ahead and have that delineator to go ahead and say, all right, this is the first process, the second process, the third process, right? And now when I go back to where I've been capturing it with a tap at the server, okay, so I put my shark at the server and capture just everything and everybody, okay, because I don't do capture filters. You all know that if you've been with me before. And then at the client site, I can go ahead and have what the client did, and I correlate that back on my shark, okay? And it makes it a lot easier. You know, what I used to do is I'd like have them, you know, do one thing and I stop and save that trace, and then do another thing and I stop and save that trace, but that like took way too long. So have them ping the default gateway, make a little batch file, all right? Then, let's see, there we go. Cable tester. I love this one. It goes inline and does duplex mismatches. It's awesome. Okay? Because you'd be amazed how much that still happens. Okay. Then, if I'm doing any wireless, which is what the trace file that we're going to look at in here was a wireless environment, then, oh, I forgot to get those out and put those in. I knew there was something else. Then I want to go ahead and have some wireless capability. So, we're going to use an Air PCAP, because remember, I use Windows. Okay. So, I use Air PCAP. It's easier. I know, bless my heart. You know, and it's funny too, because I actually dual boot into Mint, you know, just to practice, because I figure if I just make myself do it, then I'll learn it, you know. But I use Mint, you know, which is like Linux for dummies, because it has every driver known to man, right? And so you don't have to like try to compile a driver or anything. And, but then the only problem is that the Wireshark in the Mint is still at 1.2. And everybody's like, well, you could just, you know, do a make and compile it and do the one. I'm like, I don't know how to do that. So I got a student to do it for me in one class. And I finally had 1.4, 1.46 for my Mint. I was so excited. And then 1.6 Wireshark came out. So I'm hoping that I could beg somebody to maybe make me another one. You know, with all the dependencies and all that stuff and everything. I don't know how to do that. Okay, so, don't be questions. Now, so I want to have, I want to do wireless, I've got to have some type of card that's capable of doing RF mode, because I've got to capture the physical layer and the data link layer from my 8211. Because if the issue is associating to the access point, or if the issue is interference, or the issue is retransmissions of the 8211 layer, I need to know that. Okay, just like we used to look at physical layer. All right. So, and I'd like a long-term capture device because I don't like to filter, because you don't know what you don't know. So I want to capture forever. Okay. Yeah. Oh, and then disclosure. I cheat and use Pilot, so because it's easier than doing it in Wireshark. But we're going to go both ways.
What do you mean you use Pilot?
What do you mean you use Pilot? Oh, there you go. Okay. So I'm like, I hear words. Okay. I use Pilot. Well, I use Pilot and I use Wireshark. Okay. Pilot, yeah. Because, you know, who's ever opened up a trace file that's bigger than, you know, a gig or so in Wireshark? Isn't that fun? It takes a minute or two. So that's why I use Pilot. Because I don't capture filter. Because I don't know what I don't know. You know? Now, if you're in your own environment, then it's not such a big deal because you know what's going on. Well, maybe you know what's going on, maybe you don't. I don't know. You know, it depends. But especially for me, as an outside walking in, you know, I have to see it all. So I never care. So I've got to parse through a lot of data. Okay. So we've got mystery number one. All right, so there's all my answer stuff. Mystery number one, users are complaining that access to the internet was slow, or, hey, access to my FTP server was slow. So were you all sniffing yourselves when you were doing that, so you know why it was slow and what the problem was? Okay, and on the guest wireless network, right, and it just started happening yesterday. Okay, the infamous, it just started happening. Who are some of the possible suspects? Let's go ahead and make a list. Okay. So far, that's all the information you've been given. Okay. Because we're going to look at possible suspects and possible accomplices. So here's your crime scene. Who are some of the possible suspects?
Client.
The client itself. All right.
Crushed Cat5 cable.
Sorry, say louder.
Crushed Cat5 cable.
Okay, so maybe between the access point and the switch, right? We've got an issue with the Ethernet cable, okay?
Bandwidth from the provider.
Cable. Bandwidth on that, I'm sorry, say it again louder.
Bandwidth from that provider.
Okay, bandwidth from the provider itself.
RF interference.
Okay, bandwidth, not enough. Okay, firewall.
Interference.
Interference.
Broadcast.
Broadcast owner. Yeah. Someone help me. Interfere.
PRENC.
Thank you. Okay, so there's... Seriously. Spell check. Right. If it's underlining red, then I'll fix it. I know we should do that. Oh, mercy. Bless my heart. Okay.
That's 7.
There we go. Yeah, really.
Right clicking.
Exactly. When in doubt, right click and it would tell me how to spell interference.
Between the computer and the chair.
I know.
There you go.
Yeah, really. IT. Yeah, there we go. Meet the seat. Okay. So, oh, mercy. Okay. So here's our crime scene, and here's our possible suspects. Okay. Yeah, really. I started off in desktop support, and I have supported accountants, doctors, and lawyers. Okay?
Doctors and lawyers.
I have served my time. Okay? All right.
Doctors.
No, but Valium is a beautiful thing. Don't be afraid to use it. Okay. So, I'm just saying. Really? So here's our crime scene. And remember the little guys down at the bottom trying to get to the great big old internet. Okay. And now remember though, the issue just started happening. So what question should we ask?
What
Yes, what happened yesterday? What changed?
Nothing.
Right. Oh, I didn't touch it. And never start without a network diagram. Because my rates actually double if I don't have a diagram to start with. I'm like, sure, you can, because I'm busy. I want to go home, make cookies for my kids, okay? So if you're going to make me huddle through this, you're going to have to pay me extra for that. So if you just give me some, I don't care if you draw it on a napkin, all right? But I need something to start with, okay? So need a diagram to start with. I'm a visual person. I need a picture, okay? So this is what it looked like. And so we could look at some of these things, did they change stuff on the firewall? All right, oh, in fact, we'll fork out, and let's look at some of these things. If it's the client, what would I look for in a trace file? In fact, let's open it up. If you've been able to go ahead and get down the trace files, everybody got it yet? Sort of, kind of, maybe?
Yes.
See, thank you. Live, you have to, right? Okay, and well, the slow network is this one. Yes, the small one is for tomorrow. Okay, the big one's for today. Okay, so slow networks today. Yeah, just a few packets. Okay. So let's say that now, and one thing y'all should know about this trace file, it has been filtered for two things. Number one, the actual issue. Number two, for the 802.11 space, I filtered out certain management frames that highlighted where I was. So some of those management frames are missing, but there are a lot of frames in there that will help us answer these questions. Okay? But some of them have been filtered out 802.11 header-wise because they obviously had the SSID in them, and I was not going to edit 2,600,000 and what have you thousand frames. So I just filtered them out. Okay. So, but you do have a lot of the 802.11 headers, 802.11 packets, management packets, excuse me, that are going to show the problem. Okay. So let's say that a client is an issue. What kind of things would I look at the trace file? So remember, I did it with an AirP cap, captured all 3 channels, and dumped it to disk with T-Sharp for about 6 hours. So that's why the trace file is so big. And if it was a client issue, what would I look for?
Slow deltas in response back to the server.
Okay. Now, you're getting a little bit too granular before we start, because you want to look big picture first and then work it on down. Because yes, you're right, we want to know what are they complaining about. They're like, well, remember the guest wireless internet access is slow. So internet access is slow, and we have to know, which internet access to what, Is the whole internet down? I don't think so. So if internet access is slow, what should we look for?
Time of day, pattern identification.
Yeah.
Pattern identification. There we go. That's what we want. We want to look for patterns. Okay. And then somebody over here said something too.
The client itself, who's complaining.
Yeah, who's complaining the most? That's what I want to know. Okay? Who is complaining the most? Because there was one. Okay? So who's complaining the most? Now, if I want to know who's complaining the most, how would I do that in my Wireshark?
Filter their IP address.
Okay, number 1, who are you and what's your IP address?
Exactly.
Now, of course, I don't know his IP address. Well, I do know the IP address right off my head. So, but let's pretend we don't. Okay, now, especially all y'all who came yesterday, what should we do? We can look for retransmissions. Okay. Now, if we've got response time issues, retransmissions. Now, why do we have retransmissions? Because we have packet loss, right? So where could retransmissions happen? Because of this. Retran, because of this. We'd have retran, because of this. We'd have retran. Okay, I didn't spell that right. Retran, there we go. And, okay, we've got a bad cable. Retran could happen there. But somebody came in yesterday for me in my section. If I want to know, back to client, one thing at a time, okay, is if I want to know for the client, and I want to go ahead and figure out, in this trace file, what client probably is the one who's complaining, what would I do?
Conversation.
There we go, thank you, because I'm like looking right at Wes, because I remember you were in there yesterday. All right, but yeah, you were in yesterday too, so conversations, all right? So, okay. So, let's see, I think I already have conversations up. Yes. Ta-da. Now.
What if that guy's not there today?
I'm sorry, say louder.
What if that guy's not there today? He was there yesterday, but he wasn't here
Ah.
today. You can test yourself
By the day.
from the client.
There isn't a network problem.
Right, then all of a sudden it's fixed, and wow, George is gone today. Cause and effect relationship. Because that's one of the things in your interview. Is it still happening? Is it still happening? And we happened to be capturing while George was there. Okay. Now his name wasn't actually George, but yeah, while George was there. And ironically enough, and this is why I keep scanning the crowd, is there is a lady here at Shark Fest that was there when this was taken. So she knows who George is. So, but she's not in the session, so. But yeah. So George was there that day. Okay, but you're right, that would be a question. You know, what if George isn't there when you have this happen? That's, yeah. You know, you bill for the whole day.
Okay.
Sorry, I got in the car, I came over.
So
You got a bing.
there was one George and not a group of Georges?
Well, that's going to be the question. You know, one complained the loudest. But the question is he the only one complaining? And that is always a good question to ask, because there's always going to be that one guy who's the first one to notice it. And the question is, do I have lots of them or just one of them? All right? And I actually have one of them. Okay. Only got one of us really complaining the loudest.
But the others are complaining.
Yes.
He's just complaining a lot.
Yes. And because of what he was doing, it was affecting other people. Yes. Little toad. That, you know, bless his little heart. Okay. And so he is affecting other people. And that goes back to the interdependency issues that, you know, the possible accomplices. All right. So we're doing internet access is slow. What big protocols are we talking there? HTTP.
443.
Okay, yeah, 443, HTTP.
Yes.
That's what I want to hear.
Yeah.
There we go. Okay, and DNS. Okay, so gonna be watching for that. Alright. So see how, you know, just asking these kind of questions gives us some help about what we should look for. Because if I go ahead and pop in a filter for response time, you know, right away, you know, I'm going to be filtering for a whole bunch of stuff, and I'm not really sure which ones I should focus on. Because there could be slow response times all over the place in this trace that may or may not be involved, which that means may or may not get to bill for, because I'm focused on the bill for part. Okay. So now, I'm just going to be honest with y'all. So now looking at our IP addresses, okay, we can go ahead and see, you know, who's talking the most. That's always a good thing to know. All right. You guys see a pattern there?
Yes.
Here we go. So now on y'all's, if you've got the files, go ahead and open it up. Go ahead and open up conversations. It's going to take a second. Look up here while you're waiting. What IP address do you notice? Yeah. Okay. So let's see. 192, 168, 160. Dot. Yes. Okay. Now. So I know he's talking to a lot of people. Now, what would I do if I want to know what is he saying? That's what I want to hear. All right, because, you know, this is Betty Land. I want to do it the easiest way possible, right? So if I want to go ahead and know what he's saying, still in this screen, where's my clicker? There it is. Okay. Let's come on over here in the TCP side. Y'all notice the pattern? What's he doing? Yeah, he's in an email.
He's got a virus.
Yeah, he's got a worm or something.
Okay, and now I'm also going to disclose, once y'all go ahead and look at some of these packets, if anyone blushes, please forgive me. I did not edit these packets. This is really actually what happened. You might not want to open each one of them on the big screen. I'm just saying. Yeah. So I'm being very, very careful about which packets I put up on the big screen. Especially since Denny's filming. Yes, sir.
This was in the senator's email, wasn't it?
Who's your CEO?
No, he just used his cell phone.
Representative did.
Yeah. because what I'm going to do is pop up over here to Pilot, right? And I'm looking at the file for the entire trace, okay? Sorry, I can't give you because then you know where I was. So looking at the entire trace, how much data here is email? Not that much, okay? Not so much. Now, bear in mind, this is taken over a 6-hour time period. So not so much that I would immediately jump to, oh my gosh, look at all that email. What's up with that, right? But now, here's a little piece I didn't tell you. This is the guest wireless network. Okay? Now, put your smart hats on now that you know everybody knows that when you do stuff, people can actually capture it, look at it, show it on a big giant monitor, right? And so we shouldn't be doing stuff that's like, I don't know, clear text, right? So so you're on a guest wireless network. Are you going to do SMTP? No. Okay. Yeah, SSL. Yeah, VPN. Yeah, we ain't doing SMTP. Okay. Now, I don't know from this part right here for email because this is a traffic type, so therefore it could be, SMTP could be POP, could be INAP, could be, blah, 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 blah. So I don't know yet that it's SMTP from this screen. Okay, but I do see email. Now, and got, some DNS traffic in here, right? Because, hi, it's internet. Okay, we're going to have DNS traffic. And then I have, there we go, highlight that up. Okay. Got like half the traffic's unknown. Don't you hate when that happens? Okay. And that is somebody's VPN traffic because I've sent that to Wireshark to see what it is. And now somebody went and kind of over here in this section said bandwidth. All right, so this would tell me whether or not I'm saturating the bandwidth from my provider. How much bandwidth am I even allowed to have? So I can see whether or not I'm saturating that. So I see that that's not the issue. All right, so going back from looking at it biggest picture-wise, if I know that bandwidth is not the problem, but access to the internet is, then now we're looking at a few other things. So let's go back to, all right, so we know that, one complaints the most, and in a minute we'll filter for him. We already saw from the conversations what his IP address is, okay? And now going through and looking at these issues, and want to look at retransmissions, go ahead here in your Wireshark. There you go. Okay. So you have all your statistics for your beacon frames, probe requests, looking at retransmissions, and I can filter for data link retransmissions, okay, in Wireshark. All right. So I could go ahead and try to get, if I'm looking at retransmissions and I want to compare number of trying to figure out, is it a physical issue? Is it an 802.11 problem? Interference, antenna tester. If anybody went to Ryan and Trent's sessions yesterday and saw the antenna tester that they were using, that kind of thing. And I see retransmissions at the 802.11 layer. Now, not TCP retransmissions, all right, but layer 2, 802.11 retransmissions. That would give me an idea of is that a problem, all right? So we send, clear to send. I send my packet. There's, whatever interference. I have to send it again. Okay. So if I could go ahead and filter for that, what kind of percentage do y'all think would be good?
Less
30%.
30.
That's the what? 30%.
Ethernet or wireless?
See,
Wireless.
that's why we're getting such big differences in numbers, in the opinion. Now, pardon me, in Ethernet, okay, if I was on an Ethernet network and any fiber was involved, I would want to see less than 0.5% retransmission rate. But that's just me. But now in a wireless environment, yeah, that's only less than 30. Okay, that's even, wow. I find a little lower than that, but that's why it's good to get a poll going. So the type of retransmissions levels, that's what I would want to do. And that's a filter that I could do in Wireshark. Now, remember I cheat though, I use Pilot because it's easier and it's prettier. I'm a girl. I like it to be pretty. So I want to go ahead and look at retransmissions versus normal traffic.
Now, was that something you'd already created for this training session, or was that just already there?
Yeah, I had all the views that I know I wanted to use for this demo. I had them all ready to go. Yeah, try to plan ahead here. So I'm sitting there in Loris's session, and I'm like opening all these so they all be ready, you know. And then I realized Gerald's sitting behind me. I'm like, oh, I should probably pay attention, right? And but yeah, I had them all set, ready to go. And all I had to do was take the views along the side. There's my pointer. My views along the side that are available, and I just drag and drop them onto the trace file. So I have the Wednesday trace file, that's all the stuff. And then I have the case of, that's one wrong. Then I have the case of the slow network, that's the one that y'all have. Okay, so, because I wanted you to see big picture-wise, if we do have a layer 2, 802.11 problem. So looking at that graph, do you think that, you know, retransmissions, you know, going back to interference and, you know, the access point itself, things like that, do you think that there's a retransmission issue?
No.
No. Yeah, that's not a problem. Okay.
But since you were talking about percentages, and we're not seeing percentages here, how are you making that assessment?
Oh, math. Yeah.
Okay, what are we looking at? Like,
Okay. Well, all right, so I have regular traffic that didn't have to get retransmitted at the 802.11 layer, right? And then I have traffic at the 802.11 layer, not TCP, 802.11 layer that had to be retransmitted because it was, you know, we did not get an app, all right? So it was physically damaged, had to be retransmitted. And I'm trying to get that comparison. And then here I'm looking at my percentages.
Oh.
No worries, there you go. There you go. Yeah. I mean, I know what the slide looks like, so, you know, I should have pointed it out, I'm sorry. All right, so yeah. Because I love this, because I can look over time for spikes. Ooh. Okay. Or I can do percentages, because my math skills are as fabulous as my spelling skills. There we go. Yeah. I can't do math. I can't spell. Yeah, really, bless my heart. So, you know, it's all good.
Kids will teach it.
There we go. Yeah, my kids as well, they're going to teach me. So, yeah, so retransmissions really are not, so now I've eliminated, you know, physical problem. Now, actually, I really haven't eliminated physical problem because we eliminated interference and kind of bandwidth packet loss. But at the access point, if I have the switch, a bad Ethernet cable on the access point, then what would I look for?
Repeat that again?
All right, so the question is, and I heard people whispers, don't be afraid to yell it out, all right? But the question was, if I have, and what in the orange, right behind you, looking at your iPad, your name was? Yeah, yes, waiting for him to look up. Help me remember your name, I'm sorry, I should remember it. Jerry? Greg, sorry, Greg. You know, I remember him from last year at SharkFest, I mean, 2 years ago at SharkFest, but I can't remember him, sorry. So what Greg said was, well, hey, what if the Ethernet cable that's attached to the switch is an issue? Okay? So if, let's say I got a bad cable connecting my access point to my Ethernet switch, now what should I look for?
Collisions,
Errors on the port.
CRC.
Errors on the port.
Errors on the port. Errors on the port. Oh my gosh, there we go. That's what this is for. Right? So I would look at, you know, if I have the switch set to go ahead and calculate, you know, give me those stats. So, you know, do a little show there, interface statistics on the switch. All right, do you have a lot of bad CRC errors? You know, be able to pull that from NetFlow stats or, you know, whatever. So if I want to look for a physical issue. Now, let's pretend that I don't have rights to the switch because the guy who has the password for that switch is not here today. Great. Okay. And my flight's at 4 o'clock. All right. So, so then what would I look for in a trace file? Bingo. TCP retransmission. So I look for TCP retransmissions to see if I have packet loss on the other side. Okay. So And you know what? I didn't do one of those views. Oh, I should have done one of those views. Well, see, and the thing is that's why I had blank lists for what could be the problems, because I didn't know what y'all were going to say. So I didn't necessarily have all the views ready. But that's okay. So I'm going to do TCP errors so we can look for retransmissions. All right, TCP errors, overview, onto the trace file. I'm going to do it on the big one to go ahead and see, you know, across the whole network. And while that thinks, okay, so if I have a high retransmission count for that environment, now what percentages do you think we should look for?
Very low.
Yeah, now we're going back to that very low part, okay? So if I have a problem on the other side, on the Ethernet side of the AP, I'd be looking for retransmissions here. Now, you know, that'll take a second. All right, so because remember, there's like what, 2 million trace offs? Oh, thank you. Okay, 2 million trace offs. Now, excuse me, 2 million packets. 2 million trace files, that'd be fun. Okay. So now, so while that processes, okay, and then we also said on the firewall, now if we made a change on the firewall, let's think about that for a minute. If we made a change on the firewall, would that affect just the guy or everybody?
Everybody.
Yeah.
It could, depending on what you did on the firewall.
It depends. Always the correct answer? It depends. Okay? You know how, like, always the correct answer, like the answer to life, right, is 42, right?
Yeah.
Okay? Right? Yeah. Okay? Exactly. So, the other one is it depends. And kind of right analogous there with 42. So, depending on what we did in the firewall, it might affect my guy, it might not. Okay? But then we would have silent discards, packet loss. So this one will also cause retrans. Okay, bless you.
What about one of the things I've run into is service location protocol?
Okay, I'm sorry, say again?
One of the things I've run into in the past was service location protocol.
So being able to find the service. Mm-hmm. Now we're going back into who are the accomplices. Yeah, because that's one of the things that I want to bring up is the accomplices. Okay. Now in response time for the accomplices. Because what often the road that you go down, because I'll be honest, I have gone down many a wrong road, okay, and spent a lot of time in what we call in the South a rabbit hole. And so, don't go down the rabbit hole. So if I go down and I'm looking at, because remember how you wanted to go ahead and filter for retrans, you know, for service response time? Well, if the service response time for the second application is fast, I'm like, well, it looks really good to me. I don't know what your problem is. What's up with that? And the issue is the accomplice, the first protocol, either a service locator or the DNS. Okay, so that's why it's so important to find out who are the dependent protocols. Okay, and look at their response time. Okay. Oh, look, now it's already done. See, it's probably been there for a while. So we did have the retransmissions. Where's my clip? Oh, there's my clip. So we do have some retransmissions. All right, but you know, yeah, 4%. All right.
Will this identify if it's coming from our one guy, that 12?
I'm sorry, here, just 1 second. And then I'm sorry, say louder.
Will this identify that this 4% of retransmissions are coming from our guy, our .12?
Okay, because we have to think about who this is and who's involved here. Well, this trace file is the one that's everybody. Okay, so all I know is I had 4% retransmission rate over a 6-hour period with people accessing the internet that I have no control over. And I don't know if those retransmissions are happening on this side or that side or both. Okay, so what was your question?
Are you assuming that that guy is not there? Because the reason I ask that is, you can straight away ask the person, your internet access is slow.
Right.
What are you trying to do?
Right.
Are you actually trying to reach a website?
Right.
So that means it's HTTP. Look at HTTP protocol
Right.
analysis, right? I mean,
Right.
can't you just...
Can I just
take
go
it
there?
that way? Yeah.
Sure, I could just go there.
Right.
Yeah.
That's fine.
Yeah, totally go there. Okay. And
But then the training session will be a lot shorter.
exactly. Thank you. Seriously. Okay, because my goal here is to get us all to think about these kind of questions. That's my goal. Okay. You know, I mean, if you just want to know what the answer is, you just watch a little 5-minute movie. Okay.
No, just a point though.
Yeah, right. And now, but what I want you to bear in mind is, because I know the end of the story, right? Is his complaint was HTTP access. If I do a filter for him, there's very little HTTP access. And the issue is all the SMTP that he's doing. So if I filter for the HTTP, I don't see the SMTP. So when I say that later, act surprised. Just, you know, because, yeah, that's what's going on. But yeah, that's what I would do, all right? And you were saying something too?
I was just saying it's the confluence of social engineering and network engineering.
Yes.
You can't ignore either side.
No, you've got to blend them. You got to do both. Okay? And that's why I have gotten a lot better at doing client sites because I've gotten a lot better at my social engineering skills, my client interview skills. And my packet skills, I mean, I'll just be honest with you, I started out with Network General. My packet skills were just fine back then, and they're not any more packety than they are now. But my client interview skills have gotten a lot better over the years. So, yeah, okay. So you got to do both. Okay. So, 4% retransmissions might be affecting people out on the web, might be affecting people here. I don't know, I'm not really sure. Okay. So, and I don't know if those retransmissions affect just my guy or everybody. Okay. So, let's look here in Wireshark, because I can do it in Pilot too, but it is, SharkFast, Wireshark. So in the trace file that y'all have, let's try it again. In the trace file y'all have, if I wanted to know how many retransmissions, because this has been filtered for just our guy, if I wanted to know how many retransmissions our guy seemed to have a problem with, what are some of the ways I could do that?
Expert analysis.
There we go. That's what I want to hear, expert analysis. All right. I clicked the easy button, buddy. So right on down here in the corner is the easy button. All right. So click on it. Don't be afraid. There we go. Now that'll take a second to parse. Okay. And we'll be able to go ahead and see just how many retransmissions are in there. Now, yesterday I got greedy in Wireshark and it bellied up on me and died. So everyone think positive thoughts. Well, this is parsing, all right? So that way I'd be able to see, because remember there's the management frames that are in here, and I left them in there so y'all could see them. The IP packets are just the guy, but the 802.11 packets are everybody. Okay, so that's why the ratio in your trace file is so high of management packets. All right, so just to let you know what I filtered for and grabbed out. Do I stop at 11:45 or 12:15?
12:15.
Because I'm like, if I still stop at 11:45, I'm so in trouble.
You're in trouble.
All right, so while that's parsing, I was hoping that would pop up a little faster. This is why I need a solid state drive.
Is your FTP server picking up more juice, or you think you're shutting it down?
Well, let's see. If nobody's accessing it, then it's not that big of a load. And yeah, I still have people who are downloading, so I don't want to kill it. But yeah. And I know y'all are thinking, it's like, well, yeah, this is why we capture filter. Okay. So, but that's okay, because I'm just patient, and I'll just let it run. Okay. But, all right, so while that runs, let's see if I go ahead and apply TCP errors overview onto the trace file that's just that y'all have, and we'll have a race, see which one wins. I have no idea which one's gonna, so this will be fun. Okay? That. All right, but now, in all fairness, now Wireshark, remember, Pilot's operating on a little tiny trace file, and Wireshark's working on a bigger trace file. All right, so there we go. Okay. So I have for retransmissions now, just specific to my guy, 6%. Okay. So 6% of the packets that my guys sent had T-striped retransmissions. So, you know, that's a lot higher than, you know, a little higher than everybody in total, but, you know, he is accessing the internet. I don't know if that's a problem on this side or that side. Okay. Hang on. Now, back when we looked at, let's see if Wireshark's done. Back when we looked at the conversation list. Come on, display conversation list. I should have never. I should have had expert already done ready for you. Back when we looked at the conversation list, what was the guy doing? Lots of email, lots and lots of email. All right. So now I'm afraid to even try my Wireshark, but go ahead and y'all's Wireshark do a filter for SMTP. Who has a solid state drive? Okay. So y'all, when you're done filtering for SMTP, tell me what he's, you know, tell me what some of the packages look like. Now let's go back to the discussion of the accomplices. Now, what protocol is HTTP going to depend on, or any internet traffic going to depend on? Well, yeah, it's going to ride on top of TCP, true. However, when we go ahead and browse the web, do we do that with an IP address or do that with a word?
DNS.
There we go. That's what I want to hear. Thank you. So if I want to look at my DNS server to see whether or not that's what the issue is, I want to look at response time for my DNS server. There's my clicker. Okay.
We have a friend who she has shirts that says it's always DNS. Every time.
It's your email signature.
Okay. Okay. There we go. Now, let's see. It's in here somewhere. There it is. I have a view open on the entire trace for DNS response time. Now, for those of you who've ever looked at a DNS packet, and you've noticed that there's a transaction ID, right? Everybody go. Okay. And you've noticed how right under the transaction ID there's a little line that goes ahead and connects the command and the reply in Wireshark, right? And then there's a field underneath that says this is how long it took. Okay, y'all ever graph that?
No. Well, I didn't need to until today.
Bless your heart.
Okay, so for your friend, right, who says it's always DNS, okay, and she wants to prove it's DNS, she'd want to graph it, okay. So, yeah, really. So if I want to go ahead and look at DNS response time over time, I want to see if all of the, the DNS queries that are being happening, because this guy's infected with an SMTP email relay, is affecting my DNS server and therefore affecting other people. Because remember, other people are kind of noticing it's an issue, but then I have one guy who's pitching a hissy fit. Okay. So, the DNS is causing a little slowness. Now, here'd be the part where I would have to have a baseline of what the response time should be. Okay. And so if I'm looking at this response time, hey, I only had 2 responses that were less than a millisecond, right? But I have, over 40,000 responses that are anywhere between a millisecond and 100 milliseconds. And then I have some that are getting into the quarter second. I have some that are getting into half a second. I have some getting into a second. Now, that would be nice to see over time, and looking at my response time over time. Remember, I don't know if you remember from the first view where we looked at network traffic types. Here we go. Okay. Remember, my email kind of happened, had some spikes there in the beginning, and then kind of, wandered along as we went, right? Well, looking at my DNS response time, a lot higher there in the beginning, and then, then I had another spike a little later. So being able to correlate, is my email guy really hammering that DNS server? Do y'all think that he's really hammering the DNS server?
No.
No, not really. Not really. Okay. And so actually our accomplice, our concern about the DNS server is, hey, the DNS server is actually keeping up pretty good. And when I look at response time, now if I want to look at DNS response time, should I look at all DNS responses or only certain DNS responses? Certain DNS responses. Because, remember, it's my DNS server. So if I'm looking at my DNS server, what kind of DNS responses should I look for? Okay? Well, what I'm looking for is, remember, you have cache responses and you have recursive lookup responses or iterative lookup responses. Which one should I look to see if my server has a problem?
Cache responses.
Yeah, cache responses. So I want to go ahead and only look at cache responses. How can I do that in Wireshark? Now there's no DNS traffic in the trace file that I gave you. So we can't do that. Because then you would know who it is, because the DNS server's IP address. So, bless you. So, right here quick, let's pop open another Wireshark. So go ahead and start a fresh live capture. There we go. Okay. So open up a Wireshark, start a live capture. Okay. Now, if I wanted to go ahead, oh wow. Oh, that's right, you guys are downloading from me. Okay. Geez, what's going on? You guys are still downloading from me. So if I want to go ahead and look at DNS responses, and I'm going to have to get some, because my card will only look at me, so I need to go ahead and have some type of DNS query. So I'll, flick over to Google News there for a second, and let's do a filter for DNS. So in your trace file, go ahead and do a filter for DNS. Now, who knows the easiest way to figure out if a DNS response is from cache, or the DNS response had to go out and ask other DNS servers and do a recursive lookup? Do you know how to do that? Because we can't blame the DNS server if our DNS server had to go out and ask, other DNS servers on the internet. I don't control the internet, right? So I can't look at those response times.
Would the TTO deprecate by one?
Well, I'm caching though here at the client, so. Right, because the recursive lookup responses for DNS would come back to my client from the DNS server. And I'm not capturing at the DNS server, so yeah, I can't do it that way.
You can do an NS lookup for the server that you're trying to reach, Google, and then say and know which one is local and remote.
Well, now I could go ahead and obviously do an NS lookup, right? But in the trace, my goal is to figure out how can I tell from the DNS packets themselves which ones are from cache and which ones had to do a recursive lookup. I want that magic field. Anybody know what the magic field is? Oh, okay. Well, let's talk about the magic field then. Okay. God damn. Okay, let's do a magic field. Now, because it's right there if you just know it. But if nobody ever tells you, you're like, All right. So and obviously you guys did not watch my video on the missing DNS load balancer because you would know. But that's right, because I'm not doing that one. So when you look at a DNS query response, here we go. So go ahead in your trace file, you did a filter for DNS. Now let's do a look for a DNS query response. And down here in the detail, see how you've got that the request is in packet number blah, 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 and it's underlined in blue. And if you double click on it, it goes back to the query, right? Everybody know how to do that? Mm-hmm. Cool, okay, good. And then down below it, See how in brackets it says that the time that took based on where I am capturing, not, like based on where the server sent it or based on where the client got it, but where the shark is, okay? That one took 0.052 seconds. And you see how that field's in bracket? That means that's something that Wireshark's doing for you. You notice how when I highlight a field, see how that highlights down in the hex? That means it's really in the packet. Bingo, it calculated that. So when I highlight that one, it's not highlighted in the packet, that means Wireshark calculated it. Yes, sir?
That's the time it's taking to respond to the query, right?
That is the time that it took from the time that the command passed by Wireshark to the time the response passed by Wireshark. Which is a big difference. Right, location matters. Where you're capturing, anytime you look at response time, where you're capturing matters. Okay, so that's why it's real important to remember that. It's not like the DNS server, puts in a little field and says, I responded to that in like 24 seconds. Aren't I fabulous? You know how Google does that and it says how fast it took to look up? Yeah, so you can see how great Google is, right? Yeah, DNS server's going to do that. Okay, so you have to remember that it's something that Wireshark is calculating based on where Wireshark physically is. Okay, and we're at the client, so this includes any network delay. Now, so I have that time. Now that DNS time field, that's the field that's being used here in my pilot to graph that over time. Okay, that's all that it is. So therefore, if I'm just trying to do this out of pilot, trying to do this out of Wireshark, then I would just go ahead and do an I/O graph and graph out DNS response time with the magic field filter. So let's talk about that magic field filter. Because when you do a query and you get a response, okay, see how there are answer records and authority resource records? There's authority resource records, he had to go out and ask for it. If there are not authority resource records, he answered from cache. There's your magic field. Okay. So if I want to filter for all the DNS responses that are from cache, and then I'm going to graph that in an I/O graph, okay? So I would go ahead and say that it has to be a DNS reply, right? So message is a response. So highlight message is a response in your DNS header. Okay, we're going to right-click on that because you knew it was going to be a right-click, right? Okay, I'm not typing this junk in. I'm all the way over here. All right. So I'm not walking over there. Seriously. All right, and I'm going to go ahead and do a prepare filter. Select it. Okay, so it's got to be a DNS response, right? And scrolling on down, the authority resource record count has to be 0. So I'm going to do a right click on that one and say prepare a filter, because I am going to have to walk over there and edit this. And yeah, right, and selected. Okay, so we'll do the and selected. And then, got to walk over here and not whack my head on the predictor screen. We would go ahead and say 0. Okay. So those are the responses from cache. Now, of course, and here, let's zoom on that so y'all can see it. There we go. There we go. So I would go ahead and apply that filter. And those are my cache responses. Now, if I wanted to get uber fancy, I could go ahead and add to that filter, and the DNS time field must be greater than X. Okay, so for your friend who's like the DNS, it's always DNS's fault, what would she consider a good or bad response time for a DNS server that's local? Oh, somebody make up a number for me and play along. It depends. See, now that's why. Okay, so what do y'all think are some good DNS response times? Yeah. Oh golly, you're greedy, aren't you? Okay. Because, remember, we're answering from cache, right? So I want to see response time in, go more towards milliseconds and be realistic, okay? So, okay, because yeah, you're looking at an application layer response time, layer 7 response time. If I've got, 30 millisecond response time, that's pretty good. But yeah, so yeah, I want to see, 10 milliseconds, 20 milliseconds, 30 milliseconds. Then I start to get nervous. So that'd be a great thing to add to our filter. So, hey, while we're here, whoop, oh, that's not what I meant to do. Let me try that again. There we go. So while we're here, go ahead and scroll back up to the time field, the DNS.time field, okay? And then, yeah, right click, and go ahead and do a right click on it and say prepare filter. Anytime you're going to edit the filter later, and especially if you have lots and lots of packets like I do, if you do like apply and then go back and edit it, it has to parse first, then you edit it, and then it parses again. Yeah, life is short. Do prepare, all right? So I'm going to do prepare filter, and select it. There we go. And then here, let me zoom so you guys can see better. There we go. And DNS time is like, greater than. Point, I don't know, 0.30. Oh, and I have 2 dots. There we go. Red is bad, green is good. There we go. Oh, that was supposed to be a 0. There we go. So I could say, and DNS.time is greater than, whatever. That'd be a good filter. Now, let's say I want to keep this filter. It's a fabulous filter, right? We took the time to go ahead and craft it. Let's keep it. All right. So I want to come on back. Here we go. In my filter bar, hit your filter button. And let me control out here. There we go. And here we go. It's in there. Yeah. So wouldn't it be cool if you could just type in slow DNS cache responses and hit enter and it would save it? Wouldn't that be awesome? Yeah. Well, yeah. It's always DNS. Yeah, that's what we'll call it. Right. But what I was going for was don't forget to hit new, or it won't actually add it to the bottom. It'll just show it's there now. Yeah. Wasn't that annoying the first time you figured that out? Yeah. And so.
Or 5 times.
Yeah, really. Oh, mercy. Okay, so we were going. It's always DNS. It's always DNS. That's a good filter. Oops. Spell DNS right. That's a good filter. Excellent. And then that way you've got that filter to use again and again and again. Now, meanwhile, I don't even remember now what we were doing in the other thing that we were waiting for. I think we were trying to go to expert. There we go. That's what it was. And let's see, is it still? Well, here, let me stop this one capture. Okay. We'll come on back to the other trace file. And there's the expert. There we go. And we were going to look to see how many TCP errors there were in the original trace file. Of course, we already know the answer because we did it in Pilot, but remember, this is how we do it in Wireshark. So go ahead and look at the warnings and the notes. So we've got fast retransmissions, and then retransmissions in here somewhere. There we go. Oh, yeah, right on top. So that way I can see how many retransmissions are in the whole trace file in the Wireshark. Because not everybody has Pilot. Now, yeah. So we did know that it was SMTP, right? Out of our conversation list. Now, and I'm almost afraid to do it, especially while Denny's recording. But I'm going to go ahead and filter for SMTP. Now, for y'all who've already done an SMTP filter, what have you noticed? Well, yeah. You know. That was a good one. I like that one. I asked, really, so.
Betty, how did we know that it was SMTP just through
From
Wireshark?
our conversations through Wireshark, totally. We did a conversation list, and we looked at the IP list, and we saw one guy was doing like everything.
We sorted it by.
And then we went over to, right, we sorted by top talker, because it's all about the top talker, right? And then we went over to TCP to see what was he doing. Yeah, okay. So now we filter for SMTP. You know, and my screen moved, so I think it's doing something. But, you know, and my apply button's gone. You know, this happened to me yesterday where I did stuff and it didn't work. Yeah, that's what I'm looking for. It's like, where's our progress bar? Maybe you love it when stuff doesn't work and you're trying to like make it work in front of other people.
Pray to the demo.
Look at that.
Yeah, really. I just want one SMTP packet. That's all I want. There we go. That's the one. Oh my gosh, I'm scrolling through the packets.
Try to retype SMTP, see if that'll regenerate it.
Okie dokie.
I think I have to put it in twice.
Nope.
No.
There you go.
So I hit enter and enter again and enter it again. And
Hit clear, then try.
oh, that's a good idea. Hit clear. Because yeah, I want like the progress bar. There we go. There's my progress bar.
Well, that's resetting everything.
I know. Well, you know it's free. Works out. Works it all right. There we go. So it's, you know. There. Oh, see? If I just look away, there we go. Okay. And now thinking only positive thoughts. And apply. Hey, there's my progress bar. Okay. It's these little things that we ask for in life. Okay. Did you just say meanwhile back at the ranch? All right, I'm gonna just have these 156,000 packets. That'll be good. All right, fine. So for y'all who are looking at it, especially the ones with the oh, did it work? See, I told you, I just have to walk away. Okay. So looking at those SMTP packets, okay. All right. What do y'all notice?
It's all SMTP.
Well, yeah, we already said that now. Be more specific.
That 12 address is hammering.
Yeah. So the .12 address is hammering SMTP servers, and you know it's all coming from .12.
All for rejection.
Spamming, getting rejections.
I
Okay.
see several emails that are, you know, I see Susan.
Yeah, I see Susan. Trust me.
He's spamming the whole list.
Yeah, this guy's name was not Susanna. Okay, by the way. All right. It was a guy. Okay. And really, not that I want to judge. You know, if you want to switch over, but you know. But his name was not Susanna.
It's sitting all over the place.
All over the place.
He's asking about workshops.
Yeah, and he's going to different SMTP servers. He's changing who he's going to. Yeah. He is infected with an email relay bot. This poor guy didn't even know this was going on. All he knew was, you know, my internet access seems to be slow. Could you fix that one? So up there in the front, he said, did they get him a Mac to fix that? You know, I like that. That's a good one. Okay.
So it was on his client, but not on his mail server?
Right. It was on his client, not on his mail server. And and remember, we're on the guest wireless network. Now, the funny thing was, is when he was on his VPN, he didn't do it. Okay. Now, what was the reason why was because he went ahead, sent the first couple packets to the email server on the VPN and the corporate network, and the SMTP server said, no, you know, the firewall said, no soup for you. And the firewall silently discarded. But we're on the guest network here, bingo, no firewall. So they're all flying through and flying through. Sir?
So we saw that bandwidth wasn't a problem, and it's just this particular client that's affected. Unless there's no firewall, so it's not like the firewall's proxying SMTP. Why do other people feel the pain then?
Well, and actually the DNS server was having problem in responding. Okay. I just can't give you the DNS packets because you know who the DNS server is, you know who it is. So
we see lots of timeouts and long DNS.
Yeah, there were longer response times for the DNS. And remember, you know, when you do a DNS query, you have to do that before you do the really good stuff. So you've opened up something, you're ready to go, and nothing happens, and you're annoyed, and then all of a sudden there it is. So you only have to have one slow packet for you as a human to notice it. And so the other people were complaining about the DNS server.
So did they need to update the DNS bind or something?
No, it had nothing to do with the DNS. Well, you know. Yeah. Oh, hi. Could they update the DNS bind a little bit? And we're not even going to talk about that DNS server because, oh my gosh, it sucked eggs. But I judge. But
because it can reduce spam issues.
Yeah. But this was a place where, you know, golly, like, I don't know, a university type environment where we just let stuff go through. And so, yeah, but it affects other people, right? I'm sure you've noticed in the network access here is sometimes good, sometimes low. Sir.
Okay, so how far will you go?
How far do I
go? Will you go to the guy and take the bot off, or
that's what we
or
did.
are you gonna tell somebody to do that, or are you gonna say that's it?
Well, it depends on how much they want to pay.
Right.
So you got paid for the day, right? So you left.
Hello, I like you. Yeah.
Yeah. So you got paid for the day. So does that include?
Yes. Because here was the kicker. This was his response. Well, it doesn't do it when I'm on the VPN. Okay. As quote unquote, he said that. And yeah. So yeah. And you know. So yeah. What I had to do is go ahead, show this to him, and then recreate the email. Yeah. Yeah.
Wow.
Yeah.
Oh.
Yeah. Yeah.
I hate stubborn people.
You know, and the email itself is not that bad, but right. Some of the stuff in it is, some of the stuff's not, but you know, pictures worth 1,000 words.
Oh man.
Yeah.
Did you have antivirus on the computer?
Some, not good enough, but.
They were paying you to leave.
I'm sorry, go ahead.
Why was the DNS server not as VPN then?
Because the VPN access, you know, when he was doing something for work, then he, you know, was on a VPN. When he was just doing stuff, he was not on a VPN. You know, now bear in mind, I mean, I could tell, you know, this guy was embarrassed beyond all belief that, you know, he just got infected. He clicked on something he should have clicked on, and he got infected. I mean, it happened to all of us.
Betty, this is when I would tell him the activity is only happening when you're in a guest account, but you are infected and not allowed on our VPN until you fix it. Then you'll fix it without any questions asked, and you don't spend another hour showing him and holding his hand. You're so mean.
But the goal is to prove it in a trace file. I'm sorry, go ahead.
Quick question. If it's a VPN and if packets were being dropped, why was the mailbot just not continually trying anyway?
There's the kicker. It was a really good bot.
Saw that it was being ejected.
Can't make a connection to an SMTP server. Hi, if I go to shake your hand and you don't put your hand down, what do? I put my hand down. So, hi, I see sin, nothing. Then 5 minutes later, sin, nothing. 5 minutes later, sin.
Beaconing.
So it was a single tunnel VPN, I take it?
I'm sorry, say louder?
Single tunnel VPN then, right?
I don't remember now, I'll be honest.
Well, must have been a split tunnel of the SMTP control, right?
So I would be looking for those kind of patterns.
Why didn't the internal guys notice that?
Yeah, probably got
Well, remember, going back to the why, right? Time and expertise.
The bit count was low.
Mm-hmm.
With all this traffic, it wouldn't have been, certainly a fair amount of traffic just going out between the server saying, hey, can you guys switch it?
Well, now, there's the question. Okay. Now, remember we had big spikes in HTTP and big spikes in unknown, which is actually one other guy on the VPN, okay? So those were taking up lots of bandwidth. But the reason that, this guy's perception of slowness is because the bot was sucking up CPU cycle. All right, and the reason the other people were having issues is because of the DNS. So,
bandwidth with garbage.
I'm sorry, Rob?
Overloading the bandwidth with garbage, not exactly data size, but all the requests. There's no room for any more requests, and they're getting dropped.
Well, actually, all these are going out. It's not that high a volume as far as, number of bytes wise, okay? But it is a high number of things. That's why it's affecting the client. So he's not actually filling the pipe.
No, it just
right.
Just
but it is right. It is, and it's not hitting just a single SMTP server. It's hitting multiple ones. It's not going to his SMTP server. It's going out to lots of SMTP servers. Okay. So that's why he's the one feeling the pain. Now, when it's going to the SMTP server, then what would happen is everybody would be complaining about email. So it's actually going out to all sorts of email servers.
Okay, that's what I was trying to say. I guess
Yeah. It took me a second. It took me a second to see that. All right.
So their desktop support didn't look at the computer to see if it was busy at all.
Hey, I don't judge. I just catch